How's it going? This is Group 4 of the NAE project on nuclear fusion. My name is Martin Reyes, and we're going to go ahead and go over our group script. So, as soon as you launch it, the first thing you'll notice here is our main menu. Now, we've got several different sections. I'll post some images as to where in the algorithm we are as we go along. But we're going to go ahead and check out this first section here called What is Fusion? Now, the general idea about what is fusion is to help educate and inform those who maybe have never heard about nuclear fusion as an energy source in the past, have an idea about several questions and aspects of it. And so, as you can see here, the general idea is that we have a message box that contains some information and a figure with a diagram that pops up. If you click on the little hyperlinks that are outputted into the command window, when you're done running the program, they'll actually pull up the site, the website that we got our information from. And so, as we're checking out this little animation right here, I'm going to go ahead and point out that if you try to close out of it, this is the only one that gives an animation, but if you try to close out of it, it actually reopens. I'll do that again. There it is. It reopens. Sometimes you have to make sure you click on it from your taskbar, but here it is. It's still going strong. And just close this message box. As soon as it's done playing, we're going to be prompted if we want to repeat it, and we're going to say no because that was kind of long, and we're going to go back to the main menu. And so now I'll let the folks who worked on Y Fusion talk about their scripts.
Alright, hello everyone, my name is Robert and I will be covering the comparing power outputs portion of our code. So we have our main menu right here, you're going to click on Y Fusion, and then you're going to click on compare power outputs. So we have wind, solar, coal, and natural gas energies to compare. So let's go ahead and click coal. On the command window, it's going to show you how much more kilowatt hours nuclear fusion produces than the user selected energy source in a 400-second increment. The first thing that is going to pop up is a message box explaining and defining what kilowatt hours is. I'm going to go ahead and press OK for that. So there's going to be a bar graph with a legend, uh, a bar graph comparing your user selected energy source to nuclear fusion, and you're going to see how that's manipulated every time we change the energy source. So it's going to ask, would you like to compare another one? You're going to say yes if you'd like. So coal energy is no longer an option. So let's go ahead and do natural gas. So it's going to do the same thing in the command window. It's going to output the difference in kilowatt hours, and it's going to show right here natural gas energy is now there with its power output. And if you want to compare another one, go ahead, wind energy, yada yada yada, and then you go to solar energy, and that's going to be the last one, and it's going to take you back to this comparing menu. And you can go ahead and exit this last one, and you see all four of them have been compared, and you see the kilowatt hours difference between nuclear fusion and all the energy sources.
Hello everyone, I'm Jakandu. Today I'm gonna compare the price of different energy source with the price of fusion. First, there's a menu enable users to select an energy source. If they don't choose any source, it will produce a warning and keep asking them to choose a source. For example, a user selected coal. It shows the price of coal is 11 cents per kilowatt hours, and after calculation, the price of fusion compared to the price of coal is 127.14 cents per kilowatt hours, and the price difference between coal and the fusion is 116.14 cents per kilowatt hours. Also, here's the bar graph of price of coal and the price of fusion. Here's a menu ask if users want to compare with the other sources. If they choose yes, they can go back and select the other energy source types, and it will produce a different result.
All right, so we're going to go ahead and exit out of the Y Fusion section, and we're going to go to our third and final section of our code called Aspects of Fusion. Now, Aspects of Fusion is a little bit more conceptually heavy. That's because a lot of the data we use here was from the Princeton Plasma Physics Laboratory. but we still tried to make it as digestible as possible. So we're going to check out my first section here, or my last section for this code, about how the radii of the tokamak structure where the reaction occurs actually affects many different variables in the reaction. Now, don't worry about module 1 or 2. That's just for different data sets. You could start with either one. We're going to go with module 1. So we select the size of the tokamak radii. We're going to go with 2 meters right now. And then we're at prompted to select a variable. A lot of these are very spooky sounding, but don't worry about that. Just select either one of them to plot. So we have a general idea about what fusion power is, right? That's energy output. We'll select that one. And now it's going to ask us if we want to repeat the process. You could say yes, but we're going to go ahead and say no. It does exactly what you'd expect. So this is what I was alluding to. It asks, would you like to learn more about these variables? And we're going to say yes to this. Now, again, it brings back all the spooky looking variables here, and we can just choose any one of them. So let's go with normalized beta. And it pops up a little message box here that kind of gives a summarization about the subject that you selected. If you click on this hyperlink, again, kind of like the what is fusion section, your browser will open up the source in which we got this information from. So that's the general idea here. If we go back, if we try out module 2, it'll be the same thing, just different variables, different data set. So that's about it. We're going to go ahead and go back to this menu, and I'll let the folks who worked on the other scripts in this section talk about their sections.
Hey, what's up, guys? It's Steven. So my section was about the aspect ratio of the spherical reactor. I'm gonna have to run my code real quick so y'all can see. So basically, the first thing that pops up is a little message box explaining what an aspect ratio is, so user could get a feel for like what an aspect ratio is. And a menu function pops up asking the user if they would like to visualize a spherical reactor in a 3D model. We'll go ahead and choose between a small and large aspect ratio. Go ahead and large. And so a visualization pops up. Basically what I did to create this was a mesh plot of a torus and use a function to actually rotate the plot. It actually records video of it. And menu option pops up saying, would you like to repeat a visualization? So the user could click between yes or no. We'll go ahead and click no. Select an effective inboard shield thickness. We'll go and click 0.6. And so a little message box pops up after that explaining what a shield thickness is. And then another menu function pops up asking the user to select an aspect of fusion that they would like to view compared to different aspect ratios. Go ahead and include Q engineering. So a plot shows up explaining the different Q engineerings for the different aspect ratios and also a little definition for what Q engineering is. And so here another menu function pops up asking the user if they would like to plot other topics, or if not, just click no. And that's the end of my section.
Hey guys, this is Enrique Villarreal, and I'm just going to be explaining my section of the code, longevity. And so the first thing it's going to ask you is what variable would you like to choose, and we're going to go ahead and go with the peak outboard neutron fluence. And you can see it comes out in the command window, and we can see that it comes as a pretty nice graph. It says, would you like to plot another variable? And we'll say no, no thank you. So would you like to learn more about these variables? Say, yeah, well, let's figure out what a peak outboard neutron fluence is. I'm gonna go ahead and click that. Message box comes up with the with some information. Say, would you like to learn more about these variables? Let's go ahead and say, yeah. Let's look up what the effective TFWC neutron shield thickness is. And it comes up, and we read that, and for any of those wondering what the other one could be, we could just keep going back and see what's the HTS TF lifetime in full power years, and then we'll go ahead and explain this. And all of these information is in layman's terms so anyone can understand. And then when we're done, we'll just say nope. And that's the end of the code, and we'll return to the main menu.
All right, and that's about going to do it for our code. We've reached the end. I'd like to thank my group members. We all worked very hard on this script. I'd like to thank Dr. Xu and our TA Sophia, and hopefully you will use nuclear fusion in your future or something. All right, that's about it. Have a great day.